Hello everyone. So today we'll discuss about um, data types continuation and system task compiler directives in this video. So before going to next class, we'll see what is the previous topic we had done. So in previous class we had discussed about data types and what is the value of okay, each value of Verilog input. So it's having 0 1 x and z. So I think you know that one, logic 0, logic 1, unknown and high impedance value, and the signal strength also we have discussed, weak and strongest signals supplied to high impedance. We have discussed that. Then we discussed about nets, how to declare nets by wire A or wire A B C like that. And register are declared as a REG register. And vectors, so it's a group of bits, multiple bits, so declared as wire or register, like wire open square bracket 7:0 close bracket ABC, like whatever you can get. Same thing, register open square bracket 7:0 close square bracket is register, like. Then we'll continue next topic. In Verilog, you can declare any variable or any data types like integer, real, time, arrays, and memory parameters or strings like that. So it's declared as like, so first one is integer. So how to declare integer in Verilog? So like C, similar to that one only. So integers are declared by, instead of int you have integer. There's spelling integer, full word is a counter. So here this is declared as like, so declaration of integer like this as a counter. So counter is a integer, so default it will take some value as a 32 bit, and here counter is assigned to -1. So negative 1 is stored in the counter, and it's a similar to C int. And second one is real. So real values you can store. Okay, for example 10.1 or 10 power 1, 10 power 13 can be written like this. For example 1.1 into 10 power 3 like this. This is the real number, so you can represent like this. So 4 exponent 10. So this is a notation, is a real number. 4 exponent 4 to the power 10. So you can write 1.1 into 10 power 3. So you can write like, okay. So and see, this is a number. And pi also you can declare integer. So delta number can be written like this. When you are doing testing or simulation, so these things, data types are very important. So timing verification is one of the, okay, thing we are doing in VerilogHDL. So simulation as well as synthesis. When you are doing simulation, you require, okay, declaration of time, all these things like this. So time is declared like this, dollar symbol, okay, time, like. So time is a library word to declare time. Save sim time, define the time variable. So save time, okay, is a variable. Save sim time is a variable, and it's assigned to current time here. And next topic is array. So how to declare, okay, array. So you can have any data types in Verilog like register, integer, time, real or real time, and vectors, okay, for declaration of array. So arrays may be a single dimensional or multi-dimensional also. So you can declare any types. So for example, memories, okay, you can declare depth. If you want declare depth, you can declare in arrays. So arrays are declared like this. See, one first example is register. It's like vectors only, see, but extra thing is you can write depth. So two dimensional, three dimensional, like that arrays you can declare in here. So we will discuss in that same thing in memories, almost all similar to arrays only. See here 4 is to 1. So like so for example, if you are having a memory 1 GB memory in GB, okay, of 32 bit, then 0 to 23, okay, mega, and 0 to 31, like this. So columns and rows are declared like this. So 0 to 31, and here 0 to 1G declared like this. Like this. So here declared 4 is to 0 port, and port ID is 0 is to 7. So here, so RAM for example, okay, 0 to 4 is to 0. So here 5 bits word, so you can write like 0 to 31, or 31 is to 0 here, 0. Then you can write, okay, 0 to 1 GB. 1 GB means like this, 1023 M. Or that word also you can write declare. Okay, so this is two-dimensional array, like matrix, like this. So that you have multi-dimensional arrays also. See here, depth is more, so 150 four-dimensional array. So 16 into 8 into 8 into 256. This is four dimension. N dimension array, so you can declare, but you cannot use that one. It's very difficult to use this type of arrays. A few more examples of arrays like this. So this is a continuation. So count 5 is equal to 0, means fifth element of count is 0, assigned to 0, and 100th element of checkpoint is, okay, value is 0, like this. So important it is, okay, array with registers or vectors. Vectors are single element and n bit wide size, and arrays are multiple elements, means you can declare any dimension n bit, okay, or n into n bit, like. So depth also can declare an array like this. So this is the declaration. Next topic is memories. So memories are nothing but similar to vectors only. So maximum you can declare three dimensional. Two dimensional is better, because whatever chip industry, RAM or RAM, ROM, or any memories are declared like two dimensional only declaration. So some, okay, very few cases you have three-dimensional memories. Okay. Then the last one is parameters. The parameter, sorry, another string is there. Parameters are nothing but constant. Constants are declared as a parameter. So parameters are declared like library word parameter. So this is the variable or identifier. This one port id is equal to 5. So library word parameter you have to declare first, then only you can declare like this. So permanently it will fix that value 5 permanently. For example, if you want declare pi as equal to 3.14, then you can use this one. Okay, you can use parameter pi is equal to 3.14. You can use that pi everywhere, okay, in your program like this. So like parameters and on 15:0 width. The width is now okay 16-bit fixed, and for every variable whichever you have declared, okay, width as a 16 only. No need to again declare it. You can call that as a width only. So this is regarding parameter. Next topic is string. So here in a string we can declare any characters, okay, as an input. So strings are declared like this. We already discussed that one first. So strings are declared like hello double quote hello, like okay. So this line, tab, new line, tab, percentage, plus, backslash, okay, after characteristics you can declare like this. So this is the regarding string. Next we'll move to system task and compile directives. So here it's a, actually we are not using this one, but you have to having some knowledge on this. So how to display, how to stop, how to finish, all these things comes under this topic. Whenever you want to terminate any program, then how to terminate, then you want monitor or how to stop it, okay, or how to define a task, how to include your libraries, all these things discussed in this topic. So here, so for first one is system task, okay. So for display purpose you have different types of, okay, formats in VerilogHDL. So some standard system tasks are, okay, set and routine operation. All system tasks appear in, okay, dollar symbol with keyword. So dollar symbol is nothing but a system task. So we'll discuss one lot of things are there. We'll discuss only few. So here percentage D, percentage B, percentage S, and percentage S for different types of, okay, variable, decimal, binary, string, and then. So usage is like display P1, P2, P3, Pn. Like P1 may be a binary, decimal, or string, or hexa variable, like that. So printf is nothing but a display. So whatever you are doing in C, similar to that one. So we continue here, like display ASCII characteristic, then this hierarchical name and strand, and octal, current time, then scientific format, real number, and decimal format, real number in scientific or decimal numbers like this. The examples of display task like display in open bracket, okay, whatever keyword is there, hello Verilog word like that. So hello Verilog word will be as an output. It will be displayed in the output after synthesis. With the current simulation time, it's declared as dollar display open bracket time. So current, okay, time it will display like this. So virtual address for 0 to 40 register consists of virtual address. So if you want display virtual address, it will display like this. So this is the okay, display. Okay, not only display, we have some monitoring. Okay, system task they have. So like dollar symbol monitor. So like this dollar symbol monitor. So just it will monitor the variable p1 p2 p3 and you can display that one. Okay, after that means every time it will like uh, it will monitor, so you can switch on and off by monitor on and monitor off with respect to your application. You can do it. So examples are given here. So one example here, okay. So monitor on and off, like so monitor. After that another system task is stopping and finishing. Almost all both are similar, stopping and finishing. The like difference is stop, okay. So it will okay stop the duration of simulation. Finish, it will terminate the simulation. It will stop and okay terminate the simulation. That's all. Okay, stop means it will stop it, but it won't exit. But finish means stop and it will exit. Okay, so this is the two things just remember. So finish is declared as dollar symbol finish and stop is declared as dollar symbol stop. And the examples are given here. Initial, begin, clock is equal to 0, reset is equal to 0. So after 10 nanosecond, sorry, 100 nanosecond delay, you stop the task. You okay stop assigning clock is equal to 0, reset is equal to 0. It will suspend the simulation. So after 100 nanosecond, after 900 nanosecond, so it will terminate entire simulation process. So okay, so it will exit after 100 plus 900, so 10 1000. So it will exit from the entire task. So this is regarding stop and the last topic is like compiler directive. Actually we are not using this one whenever you are okay required any new library, uh, you require this type of okay directives. So these are provided in VerilogHDL. So defined by keyword define. So dash define, the tick define is nothing but defining the directive. See like for example if you want macros, okay, or subroutines, then you can declare like this. So like in C include stdio, like so if you want to create your own library, then you can use this type of define word size 32. So automatically it will give Okay, the library word in directive like this define. Okay, dollar symbol stop, this is defined as stop, means s means stop, so you can write stop means s, like you can call that function anywhere, so like this. So, and header file dot header. Okay, so this is another type include. So include, tick include. Okay, if you want created any library like written some program, okay, for communication block, if you want call that communication block in main library, like you can include that, okay, as a header file like stdio.h, similar to that one. Here you can include header.p. So there's another thing you can, this is the advantages of Verilog HDL or any other language. Next we will conclude the topics of this second module, first half. So finally we understood that from this chapter is, okay, what are these syntax, okay, and it's a similar to C language, and almost all Verilog HDL is derived from C language and easy to learn. And we studied about conventions for operators like comment, void space, all these things. Then different types of data types, and Verilog having 4 logic values and their strength and time, array, memory, etc. We studied, and Verilog provide useful system tasks and functions like display, monitor, suspend, and finish, like that. And directive, define, and include. We studied this one. So thank you for watching this one. Okay, we'll conclude here only.